Nuclear fusion, the key to a brighter electric future. Globally, our need for electricity has tripled in the past 5 decades, with industrialization sweeping through countries such as India and China. This need is expected to triple again in another 30 years. As of 2016, coal, petroleum products, and natural gas provide for the majority of our electricity needs. Nuclear power supplies 9%, and renewable resources also contribute 9% to this demand. Nuclear power as we know it today can be achieved using a few different methods, but they all operate under the same principle of fission. Fission is the process of breaking down a single atom into its smaller components. For instance, in this case, we take the heavy, unstable uranium-283 atom and collide it with a single neutron. The result being heat and other radioactive particles. These particles are free to collide around with other particles, and they continue on a chain reaction. This reaction results in massive amounts of heat. Think of these mousetraps as the unstable uranium-285 element. Now watch what happens when a free neutron is introduced to the system. Ready?
Mhm.
Nuclear power as we know it today does not come without its costs. The biggest problem being the disposal of radioactive waste. The half-life of some of the particles involved in these reactions range from 10,000 to 4.5 billion years old. Previous failures have also cast a dark light on nuclear power. Events such as 3 Mile Island in Pennsylvania happened in 1979 when a gauge was misread and a reactor went critical. In 1986, a reactor exploded in Chernobyl, Ukraine, and in 2017 was just contained. In 2011, a tsunami hit Fukushima, Japan, causing the cooling systems to fail at their reactor and it to melt down, leaking into the outside environment. Fusion is the future of nuclear power. Fusion is essentially the opposite of fission, whereas in fusion, two particles are accelerated to the point where they fuse into a plasma-like state of matter. This can only occur under extreme temperatures and pressures, such as what occurs on the surface of the sun. Recreating conditions similar to the surface of the sun on Earth was relatively difficult until 1958 when the Soviet Union published their tokamak reactor. By utilizing electromagnets, This reactor is able to perform powerful magnetic fields. Under this immense magnetic pressure, charged particles start to behave oddly. During a fusion reaction in a tokamak reactor, two isotopes of hydrogen are used, deuterium and tritium. Once introduced, these charged particles are accelerated in the magnetic field. They move around the torus so fast that one nucleus doesn't know itself from another, and the two fuse into plasma. This fusion releases vast amounts of heat energy. As it stands, modern-day tokamak reactors can fuse these fuels into plasma. However, it is not self-sufficient, and no more power can be produced from the plasma than is put in. Here's an example of what happens at the molecular level during a fusion reaction. Fusion energy, as we know it today, is going to change in the coming decades. Plans for the International Thermonuclear Experimental Reactor, or ITER, started in 2006. Construction began promptly in 2013 and is expected to be completed in 2021. ITER is located in southern France and is being funded by some of the world's superpowers. Much like the International Space Station, ITER serves as a globally owned research facility for the advancement of fusion energy. The ITER is over 10 times the size of any of its 200 predecessors and is expected to be fully operational by 2035. Unlocking the key to fusion energy will be beneficial to all of mankind. Compared to fusion-derived nuclear power, radioactive byproducts from fusion break down in decades compared to thousands of years. There is no harmful gas emissions to the atmosphere associated with fusion, only water vapor. Fusion reactors can be built for smaller, localized stations in the near future. Fuel for fusion reactions are considered limitless and can be found in common seawater. This altogether will lessen or eliminate our reliance on fossil fuels to generate electricity for our world.